So before we get into the fancy demos of looking at Hive and Pig and Impala, it makes sense to start instead with a very basic demo of running a streaming MapReduce job right at the command line in our PuTTY window. And you see that we're at that very command line here. Now, rather than sort of type all the necessary commands freehand, I have them in a text file. Let's switch over to that text file and take a look at what we've got going on. The first line of code, if you will, the first command, will create a new directory just right in our home directory on the Linux host that is the master node in our EMR cluster. So we're creating a new folder, and then we use the wget command to pull down a sample Python MapReduce piece of code that implements a very classic MapReduce sample called word count. The file itself is wordsplitter.py. It's a Python file, and it's in the word count folder, which is within the samples folder, which is within a public S3 bucket called Elastic MapReduce. S3 files can be reached over HTTP, and wget is a nice command line utility that allows us to do HTTP downloads. You'll notice that before we specify the S3 file that we're getting, we are also specifying its destination, which is the streaming code folder in the current folder in our local file system. And doing that requires that we use the -O switch on the W command. Once those two steps are complete, we'll be able to run our MapReduce job itself. We do that by calling the Hadoop command, logically, and telling it to go into jar mode, which means run a MapReduce job from a Java jar file. We tell it specifically to look in a local folder called contrib, a subfolder underneath that called streaming, and then to look for hadoop-streaming.jar, which is the built-in Hadoop jar file for doing streaming MapReduce jobs, i.e. MapReduce jobs where the mappers and reducers are written in languages other than Java. We tell it which external file to use, which of course is the file we just downloaded, wordsplitter.py, inside of the streaming code folder. We tell it that wordsplitter.py is itself the mapper, that the text input for this word count exercise will be the contents of a folder called input underneath the same S3 bucket and directory structure from which we downloaded wordsplitter.py itself. Finally, we tell Hadoop that the output of the MapReduce job should go to a folder called word count out underneath a folder we've already created in HDFS called streaming code. And we call a built-in reducer function called aggregate, which understands that it needs to take the key value pairs that have been output by the mapper and add up all of the values so that it has an aggregation for each unique key. So with those three commands explained, let's run them one at a time inside of our PuTTY window. We make the directory. We download the file. Believe it or not, that's not error message text you're seeing. That's successful status message. The download is 100% complete. And now that we have the file, we can run the MapReduce job. And what you don't notice, but what I'll tell you, is that in each of the cases where we pasted the command inside of the PuTTY window, I did that by right-clicking the mouse after the appropriate command had been put inside of the clipboard. Now, if you take a look, we're running our MapReduce job, and presently the map and reduce phases are each at 0%. It won't be too long before the mapper reaches a larger percentage, and then it'll take a while for the entire job to finish. We're at 8% on the mapper now. So we're going to hit the pause key here, and then we're going to go ahead and come back to you once the job is done. We're back now, and our mapper phase is almost complete. We're at 92%. Pretty soon that'll tick up to 100%, and then the reducer will kick off. I'll give you a bit of a spoiler here and tell you that the reducer will complete to 100% rather quickly and in only one step. And once that's done, our entire MapReduce job will be done. And we can go back to our text file and look at a few more commands that we'll use to view the output of the MapReduce job and then clean up the files and folders that we've created. So the MapReduce job is done. We'll come back over here, and in this case we're going to be running another Hadoop command, but this time rather than putting it in jar mode, we're putting it in FS mode. FS like file system, like HDFS. Then we follow the FS by a dash and then a file command for HDFS. In this case, the cat command, which will display the contents of text files. And rather than giving it a single file to display, we're telling it to display all the files in the word count out folder that we directed the MapReduce job to put its output in. This way we don't even need to know what the output file name is in order to see what's in it. So we'll come over to the PuTTY window. We'll type clear so we can get a clear screen and go back to the top. I'll right click with my mouse, and soon enough you're going to see a list of words and a count of each stream by. We're already at the Z's, of course, and so we're done. We'll come back over here though, and I'll just show you the cleanup code. The first two commands are HDFS commands that will remove the word count out folder's contents, and then we'll remove the word count out folder itself. Likewise, back in the local file system, we'll remove the contents of the streaming code folder and then remove that folder itself as well. I'm going to put all four commands into the clipboard. I'll type in clear once again. I'll right click once again. The HDFS commands take a little while because every HDFS command has a little bit of delay associated with it. But pretty soon this one will finish, and then the two Linux commands happen almost immediately. So we've now done a streaming MapReduce job, looked at the output, and then cleaned it all up in one very nice demo.